Welcome all. Today we're going to talk about Azure automation with Azure Functions and Event Grid by the amazing Microsoft speaker Massimo. So welcome and thank you for coming to our learning room today to discuss Azure Functions and Event Grid with us.
Thank you, Luke. It's an honor for me to be here. So thank you very much.
I know it's quite late your time, so thank you very much for staying up and talking to us today.
Oh, it's a pleasure. It's a pleasure. So I'm very happy to be here.
This session is delivered as part of the Microsoft Learning Room community. So Azure Cloud Commanders is the learning room that I run. It's a Teams-based community initiative where we run sessions like this. If you've got questions about certification and exams, you can ask, or Azure in general, you can ask and we'll do the best to help. There's learning rooms about like Azure infrastructure and administration, like the Azure Cloud Commanders learning room, and there's learning rooms about Azure Fabric, data. We've got AI learning rooms as well. So if you're not already a member of these learning room communities, come on board and join as many as you want. They're all free, just we're offering up our time to help you. So this session is being recorded for those who cannot make it today. If you do not consent to be part of a recorded session, please disconnect your line. This session is an inclusive session. We've got people from all over the globe at different technical levels as well. People who may have been working day to day with Azure Functions as an example, and then people that may have only heard what it is today. So be welcoming, respectful, be friendly, open, be understanding of differences, kind and considerate. Feel free to raise your hand, well, the team's virtual hand, if you want to ask a question or put it in the chat. I believe there's time at the end for Q&A, so make sure during the presentation that you think about all the questions that you want to ask. Feel free to mention it in the chat. And if you do come off mute to ask a question, just make sure you mute yourself again when you're not speaking. So with that, I'll hand over to Massimo for an introduction and the great session we're going to have today. I'm quite excited. So thank you, Massimo. Over to you.
Perfect. So I start to share my screen. Tell me if you see my screen, please.
Yes. Yep.
Yes, perfect. So thank you to invite me. My name is Massimo. I would like to introduce myself. This is the first session about a series of 2 sessions. We talk about automation in Azure, and we talk about automation with serverless. So we will see in the 2 sessions, the communication part, so the event part, grid and alert, and also the compute part with the function this day and logic app next event. My name is Massimo, as you can guess by the name and also by my English. I'm an Italian guy. I live in Rome, in the center of Italy. I have 30 years of experience in the IT world. That I am a developer, so I become as developer, then technical lead, and so on. Now I am a technical speaker in Microsoft. So every day I talk with people, with our customer, and I explain Azure. I explain the compute part of Azure AI in this moment, and you can have you can find my reference here, but I give my reference also later during the Q&A. So let's start from the beginning, and we start from the definition of automation. This is the International Society of Automation definition of automation. So the automation is the technique of making an apparatus, a process, or a system. In our case, our resources in Azure that operate automatically. So we need to find a way to understand that something happened and then react to do something. So we need to components for the automation. The first one is the component that understand, that observe a resource and observe a condition over a resource and understand a changing of this resource and then allow us to do something. In particular, we have a lot of this kind of components in Azure, but we talk about events and alerts. The difference is events is something that a resource throws in Azure. Alerts is something that happened in the monitoring part. So we will see next time. We can consider timer also a React mechanism. So timer is every amount of minutes you do something. So for example, if you need to rotate a keys in Azure because your front end use a key to access to a storage or external service, this is something you can do a timer, but it is an automation. You don't react to an event, but you have a timer that every certain amount of time, 5 minutes, 10 minutes, I don't know, every morning at 8, you do something. This is the React part. It's important because you need to understand that something happened and then you need a compute part. The compute part is the component that perform the automation task. The technology you can use is you have a lot of technologies you can use in Azure, but we use serverless because in the next slide I show you that serverless is perfect for this kind of task. Why is perfect? First of all, because serverless is event driven. So event is something that happened. So if you look to a resource and you know that something happened, you can react with a serverless technology, so a function or a logic app, first of all. Second, the scalability. Serverless scale automatically. So you don't care about the scaling. You don't need to define rules to scale your tasks, to your automation task, because it's something you have built in for in serverless technologies. Third, the platform. If you look at the function, we will see the function in this session. You have all the platform. You just need to focus on business logic. You need to write the lines of code to do something. You don't care about the hosting. You don't care about something similar. You need to write only the business logic. So the line of codes you need to write is less than in a standard web API or batch or something similar. And finally, the cost efficiency. Serverless technology, you pay only if you run something. So if you need to react, you pay. Otherwise, you don't pay anything. So it's good because it's the minimum amount of money you need to spend. If you create a batch and the batch every minute check something, you need to pay for the compute part. In serverless, you don't have to pay. You pay only if you have a run. If you run a function, you pay. Otherwise, you don't pay. So it's good for us. So we start from the event grid. Event grid. What is event grid? Event grid is a event routing. So it's an engine that you have in Azure that allow you to catch an event produced by someone, a resource or an external service, and routes this event to an handler. Okay, so this is the React part of our automation. What is an event? Event is important because an event is the smallest amount of information that fully describes something that happened in the system. So, for example, if you take a look on a storage, as someone create a blob in a storage, I will show you the demo in a while. The event tell you, hey, someone create a blob in a storage. So this is the name of the blob. This is the time when the event happened. And of course, the event is a blob created. That's all. But you know that something happened. So an event generally you can have a discrete event or a streaming event, but in automation, generally you have discrete event. Discrete event means that now happen an event, after 10 minutes happen another event, and so on and so on. So you don't have a streaming, and also every event is a complete event. So you don't have a chain of events, okay? Just only event is actionable. So you have all information in a single event. Just to make an example, this is some custom events, order creates or account changed or number of user logged. Generally in Azure, the event has this schema. So every event, no matter what is the source, produces the event as this schema. So topic, subject, event type, event time, and data are always the same. But here you have the data of the particular event. You can imagine that an event you have when you create a blob is completely different from an event you have when someone create a secret in a Key Vault, or when someone stop a website. Oh, yes, from the data perspective, is completely different. But every event has the same schema. It's important that you maintain the same schema when you use your custom event, because you can create your custom event, okay? But because you can manage your application, the communication between your components in your application using the events. If you maintain this schema, you can leverage a lot of features you have in Event Grid. I'll show you in a while. Generally, when you receive events from Event Grid, or at least when the source send events to Event Grid, send events in an array. So back again, this is an array because you have the parentheses of an array, and even the source produces only one event. You have an array of event. Okay, it's important. Then you have a limitation about the size. I am talking about the basic plan of the Event Grid. Now you have another plan in Event Grid, the standard. You have more space, but for our demos, for our session, the basic is enough. But you have a limitation. You have 1 megabyte of event. You need to remember that event is the smallest amount of data. So you don't need a lot of space. Just you need to say what is the event, when the event is happened, and some information about the event. So you don't need a lot of space. But you have 1 megabyte of space for the array and for the single event. So you can have an array with one event of 1 megabyte of size, or I don't know, an array with 2 events with enough for megabyte and so on. But this is a limitation. You have this limitation. And also, when the Event Grid routes the events it receives from the source, the events are sent to the subscriber. I show you the architecture in a while, in an array with a single event. So if the source produces an array with 2 events, the subscriber will receive 2 calls with 1 event and another event. In some scenarios, for example, if you use a function, you can batch this. You can create a batch of these events, so you will receive one single call with multiple events. And finally, you have 2 schemas. Honestly, you have 3 schemas, but the custom schema, as I said you before, is not the best for you. You have 2 schemas. The Event Grid schema is the schema I showed you previously. Another one is the cloud schema. You use the cloud schema when you want to communicate between different clouds. So if you want to communicate between Azure and AWS, probably cloud schema is the best because it is a standard. If you remain in Azure, probably you can use both. Event Grid schema is perfect. Okay, it's perfect. What is the capabilities of Event Grid? You have basically Event Grid is a publish subscribe. So you have a publisher someone produce an event, and you can have multiple subscribe. What does mean? It means that in the future you need a more feature. You can add a subscriber, so you don't need to change anything in place. You need to add, and if you add, probably you don't break anything in place. Probably the worst case is the new component is not working, but the other it's okay because you don't touch anything. Okay. You can filtering the event, so you can say I have an event. I want that a subscriber receive event with this category, with this characteristics. So I don't know, with some data in the data property, and the other subscriber receive another kind of event. So you can filter the events. You can create some policies of retry. So if your subscriber is in the moment of the routing of the event is down, you can say, hey, event grid, retry every, I don't know, 10 minutes for 24 hours. Okay, you can implement some reliability rules, and also you pay for event. I show you a slide in the end of this first part of the session in which I give you the number. I give you how many dollars, how many euros in Europe you need to pay for each event. But you pay for event. So it is a serverless technology, because if nobody throw events, you don't pay anything. So it's perfect. If you need to manage an automation, you pay. Otherwise, you don't pay anything. Remember, when you work with the cloud, the cost is not a secondary topic, because every time you use something, generally you pay. So if you have a technology that you pay only if you use, it's perfect, because in the case you don't use the technology, you don't pay anything. And you have some built-in events. So what does it mean? A lot of Azure resources, the storage, Cosmos DB, and the Key Vault, and the app configuration throws events. So you can say you can manage some aspect of these resources. So if you want to do something when someone creates a secret in Key Vault, you can, because the Key Vault, every time someone creates a new secret through an event, so you can catch this event and do something. I show you in the demo. This is the architecture. So you have a set of sources. The event source is the resource, is even an external cloud. As you can see here, you can have external cloud or your custom events. So when you create your custom events, you can communicate between, you can create two components of your application that communicate each other using the events. You decoupled this kind of component, and then you can communicate. It's similar to the message when you use a service bus, but the event contains less data than a message, so it's quite similar. But anyway, when you use Event Grid, you create the topic. You create topic, and the other arrow, that name is subscription. So you say, hey, I want Event Grid. I want that, for example, every time, I don't know, let me, an example. Every time an event, a blob storage produce an event, you use a topic, you create a topic and redirect this topic to a subscription. So you say, hey, Event Grid, take the events produced by a particular resource and redirect routes that events to a handler. An handler must be a function, maybe a function, maybe a bus, a service bus, maybe a logic app, also maybe a custom webhook. So you can, for example, create something in another cloud, expose a webhook. the webhook must be do in a particular way, must receive a set of events to check if the webhook is okay. But you can create a webhook in another cloud and then communicate from Azure to the other cloud. So it's very powerful from this point of view. Okay, we will use the function in this session, but you can use what you prefer. And also, because it's a public subscribe, you can have a function that do something, a service bus to communicate with other components, a logic app to do other stuff, and so on. So you can have multiple handlers, okay, because it's a public subscribe. Then this is a push delivery approach. So someone throws an event, and the event will push to the handler, okay, to the final handler. When you use push delivery, there are particular scenarios. So, for example, you need to communicate between your components or between Azure services or partner services to your application or from your application. So it's a way to communicate between components in your solution, but also with the different solutions. When you want to check when something happening in a system, so instead of polling a system to check the change, the system can throw an event, and then you receive the event will be pushed to you, and you are immediately informed that something changed. Or when you want to you have an application that cannot make outbound call. Imagine you have an application in your on-prem, and this application cannot make outbound call, but can expose an endpoint. So from the Azure, you can send the event, because that endpoint may be a webhook, and you can use that webhook like handler. So your application can receive data, even the application cannot send anything outside. So it's a way to solve some particular problems like this. So we can have a little demo. So let me open the. I created this resource group this morning. It's my morning, because now it's evening, and I want to, for example, check. When someone create a new secret in this key vault. First of all, let me go, go there. Let me move this one. Let me refresh this one. This is an event grid viewer you can find in the reference of my demo, my slides. Yeah, I put the link. This is a container you can deploy in an app service and expose a webhook compatible for the event grid. So in this using this viewer, you can see the event that the event grid push on the endpoint. So I will use this one just to show you the event. So first of all, let me copy this one because I need it. I go here, I open the Key Vault, and in all the resources that throw events, you can find these blades. These blades is the blades in which you can manage the topic you will use to route the events from this resource to your handlers. And for example, I go there and I create a new subscription. Remember, you need to create a topic and subscription, and then you can add more subscription, but at least you need to have one topic and one subscription. So I give a name, Learning Room. This is the name of the subscription, sub Key Vault, just a name. You can use Event Grid, Cloud Event, or custom input. For my experience, I never use a custom input. I use an Event Grid or Cloud Event if you need to communicate to different clouds. But I use this one. Now I create the name. I give a name to the topic. You create a topic, and inside the topic you have one or more subscription, at least one. Otherwise, it's unhelpful. Learning Room topic key vault, just to give a name. Okay, I suggest you to give best name that I use, but this is a demo, so I can do it. Then what kind of events I can manage for key vault? You can see all events related to certificate. So new certificate, near expiry, expired, the same for secret, the same for key. So, and also when you change the access policy is the one of the way you can give credential to an identity to do something in the key vault. In my demo, I want to just to have this one, secret new version. So I want just to be informed when someone create a new secret, just enough. You can add more than one. So this is one of the filter you can have in the event. And then I can choose the endpoint. As you can see, I have a function, an alert. This is a new endpoint. Another event grid. You can chain one event grid to another one. Event tab hybrid connection is what I mean when I say you can communicate with the on-prem service bus queue, topic, storage queue, and webhook. Now I use webhook because the event grid viewer expose a webhook. So let me choose this one and configure the endpoint. I just need to give the URL. The real URL is this one, dates. Let me write. What's happening when you confirm the selection and then you create? The first thing Azure does is creating the topic and then try to create the subscription. When creates the subscription, Azure sends a particular event to the endpoint, in this case the webhook. And the webhook, if you go to the documentation, you can find all the information. And the webhook need to return a particular code it receives in the event. It is just to check if the webhook is valid. If you put a not valid webhook, the subscription will be not created. So why? Because if Azure creates a subscription, but the webhook is not valid, every time you the source throws an event, the Azure try to deliver the event, and you pay for that delivery. But there is nothing on the other side that can receive the event, so you pay for nothing. It's not good. So Azure doesn't create the subscription. In this case, if I write all the things right, create the topic and then probably receive that the subscription is okay. Finger crossing. Okay, perfect. So it creates the topic and the subscription. And if I go to the event grid viewer, here you can see I have an event. And if I look, I see that this is an array of events composed by one single event. The event is generated by this one. This is the resource ID of the key vault. If you look, subscription, resource group, providers, and then the name of the resource group. So this is the name, the resource ID. Sorry, not the name, but it's more complete. The resource ID of the source. This is the subscription validation event. This is an event. A particular event is an event of event grid. Now we try to create a secret. So we will see that we receive another event, and then this is the data. In this case, data is only the code, the URL. This is the code the webhook need to use to respond. The response to the event grid to communicate, to complete the creation of the subscription. So let me delete. So now the communication between the events of key vault and my handler is okay. So I can go to the here, go to the secrets because I use the secret creation. My amazing secret. I don't tell you the value because it's a secret. And that's all. Let me Why? Yeah, just because I need to give to me the right credential. Sorry, I forgot to do this morning. Sorry, but so let me give an assignment. So I cannot create because when I create the key vault, I don't give to myself the role to creation to key vault. Let me check.
Yeah, those data plane roles can be quite a pain, eh?
Yeah, just because when you create a key vault now, it use the role-based access approach, so you don't have the let me go to the secret officer. This one is enough, I think. Next, let me select the member. You know Massimo? You don't know Massimo? Sorry, but the name is Bonanni. Oh, why? Why not? Now let me write. Okay, I don't know why it doesn't recognize me if I don't complete the user, but it's okay. Let me review a sign. Come on. I'm sorry, but I forgot to add the role. And now we can try again. And I hope it works. Amazing secret. I hope the role is okay. Perfect. So I can create, I create the secret and I receive the event. Secret, new version created. And just a little thing, you have the name of the secret, you have the type, it's a secret. What is the vault? But you don't have the secret because you receive that the event that someone create the secret, but if you want to read the secret, you need to have the credential to read the secret. Okay, so there is no problem in security. If the event contains the secret, may be a problem for the security point of view. No, in this case, you don't have anything. You have the URL. So if you have the credential, you can read the value of the secret. Otherwise, you cannot. So this is how basically Avangrid works. So it's very, very easy. Now let me close the one. We talk about money now. So how much cost? You have $0.60 every million of operation. So what is mean operation? Every time you draw a resource throws an event, you pay one operation for the topic and one operation for every delivery in the subscription. So in my case, the new secret cost 2 operations, one for the topic and one for the subscription, 0.60 every million. And also you have a 100,000 operation free in a month. So if you want to, the cost is not so high. Of course, depend on the number of events you need to manage, but it's not so high. So if you want to, we can have an example. So imagine this is the final demo. You have an Azure function connected to a blob storage through Avangrid, and every time you delete a blob, the Azure function restore the blob itself. So you delete, after 2 seconds, you have the blob again in the storage. Imagine you have 1 million of blobs every month. You publish 1 million of events from the storage, and you have 1 million of events delivered to the endpoint, to the function. You pay, if you make a calculation, $1.14. So it's not a big amount of money. I can imagine you have other resources that cost a lot of respect of this, more than this. Okay, so perfect. The compute part, Azure Functions. What is Azure Function? Is a serverless solution. So what does mean? You don't care about the platform. You don't care about the plumbing code to run your function. You just look at the business logic and you pay every time and only every time your function runs. So it's a serverless. Okay, it's perfect. And also you have event-driven scalability and so on. So the cloud infrastructure provides all for you about the hosting. You don't care about the hosting. You write the code. Okay. You have your Azure function. Your Azure function can be written in different languages. You have C#, Java, Node.js, Python, or PowerShell. And also if you want, you can use another language, whatever you want. There is a way to communicate between Azure function and another language. For example, Go is not the best way because there is a communication using gRPC between the two components. So if you want to use function, I suggest to choose one of these native languages. So C#, Java, Python, Node.js, PowerShell, it's enough, I think. Okay. Your function run on a runtime. Azure Function Runtime is the runtime that allow you to run the function and give you some components I show you in a while. The most interesting thing of the runtime is you can run on your PC. So you can run your function on your PC and you can debug your function on your PC. I will show you in the demo. You can run in Azure. There is a function app. You have several plans you can use. I show you in a while. But also you can containerize your function and the runtime in a container. What does it mean? You can run whatever you want. So you can run in a Kubernetes. You can run in a container apps. You can run whatever you want. Okay. Container apps is perfect. I show you in a while. But if you want, also in Kubernetes. The platform, the runtime, it gives you a component, the trigger. The trigger is the way you can look at the event. So, for example, you can look to a Cosmos DB, and when someone add a new document in a Cosmos DB, your function will be run. So the trigger run your function when something happened. Of course, there is a trigger for Event Grid. So you can say, hey, if an event arrives from Event Grid, your function will start. But your function probably needs to communicate with the external world. So we'll start when something happened. When the trigger starts your function, the trigger gives you a payload, a class, if you are in an object, if you are in C#, with the data of the events. But you need to communicate with the external world. So the platform gives you another component, another set of components called binding. So you receive an event, for example, from Event Grid, and you want to write in a database. You need the binding to write in a database. Is not the only way you can use to communicate with the external world. I will show you in the latest demo. You can write your own service and use dependency injection to inject this service in your function. But this is the full picture of the function. So your function is a piece of code, is a snippet of code run in a runtime. The runtime provides you a trigger that allow to run your function when something happened and provide you some bindings you can use to communicate with external services like a storage, a Cosmos, another Event Grid, and so on. Okay. Hosting, you can, I told you, you can host your function in a different way. This is the native hosting because you can containerize your function. You can run in a Raspberry, you can run in Kubernetes, you can run in your application, in your PC, in Docker. This is the native. I would like to communicate show you only the plan, the native plan, because it's I think it's the best using the native plan. So the first one, consumption plan, is the default hosting plan. It is a true serverless hosting. What does it mean? You pay only when your functions are running, and the scalability is automatically. And also, I will show you in the pricing slide, you have 1 million of execution free every month. So for the most for a lot of scenarios, you don't pay anything. 1 million is enough. 1 million is exactly the demo I mentioned you before when I talk about the price of Event Grid. So if you have a storage, and every time someone deletes a storage, you run a function, and the scenario is 1 million of blob deleted every month, 1 million of execution, you don't pay anything, okay? This is a new one. Flex consumption is something arrived 3 months ago, 2 months ago, if I remember well. What is the problem in consumption plan? Because you don't pay anything for 1 million, because the cost is the cheapest, okay? When you don't use your function in a consumption plan, your function will be removed from memory. So if a trigger wakes up your function after a while, the plan needs to start the function. There is a cold start time. You need to wait before your function is up and running. In the flex consumption plan, you don't have the cold start. You have less cold start timing. You have support for virtual networking. You don't have in consumption plan. If you want to secure the communication between some resources to your function using a network with consumption plan, you cannot. In flex consumption, you can. And also, again, you pay when your function are running. Is similar to consumption plan. You don't have 1 million of execution for free and scale automatically. Okay, it's the same, but you don't have the 1 million of execution for free, but you have network supporting, virtual network supporting, and also the cold start is less. The premium plan is the most efficient, but you pay. You pay is not serverless. You pay an amount of money every month because you have something that your runtime is up and running every time. So you don't have the removing from the memory like the consumption plan. So it depends on the scenario. If you need to react every day or you have a timer every 5 minutes, probably consumption plan is the best. If you need to scale because you receive a lot of events, for example, in IoT platform, probably it's the best is premium. So it depends on the scenario. The worst thing is you cannot change the plan when you choose. So if you create a function plan, a function app, sorry, the resource that contains your functions, and you choose consumption, you cannot change. You need to create a new one with a different plan. But you use infrastructure as code, so probably you have a pipeline, so it's not a big issue to create a new one. So it's perfect. This is the characteristic. I don't like to write more text, but here it's important because I give you the slides after this session. Dedicated plan is like the app service. If you know what is the app service is the web hosting. When you create an app service need an app service plan. App service plan is the compute part. You pay for that app service plan, a fee every month, depends on the power. You can take that app service plan and say, hey, I want that my function run on that app service plan. In this way, you don't have a serverless because the scalability is limited by the plan. Okay. Yeah, but you can reuse a plan that you use for an app service, for example, for a front end. So the front end and your function can run on the same app service plan. It's another way. And also you can leverage the app service environment if you want to deploy your function inside a network. With the consumption, the flex consumption and the premium, you can integrate with the network, but your function run outside the network. With the dedicated plan, and in particular, when you use app service environment, your function run inside the network. It's completely different. Finally, container apps. Container apps, you can imagine container apps like an abstraction of Kubernetes. You don't want to manage the cluster. You just want to have the orchestration features of Kubernetes. This is container apps in 2 words. You can containerize your function with the runtime and run inside container apps. So it's another way to run your function. So just to show you that you write your function one time and you run in a different plan. Depends on the scenario. Depends on the scenario and also depends on the cost you want to pay, because consumption is the cheapest. Premium is probably the the most expensive. Depends on the scenario, of course. But what you can do locally? You need to have Azure to test your function, to deploy your function, no, because you have a tool, Azure Functions Core Tool, the name. This is a tool that contains the runtime and also a set of commands that allow you to create a function in every language supported. So Java, for example, I'll show you in a while. And you can run your function locally to test locally before you deploy. And also you have the command to deploy in a container app, to deploy in consumption, to deploy to Azure. So you have a lot of feature in this tool. Basically what you can do. The first command is a func init. Func init tell to the tools, hey, I want to create a new project for my function. Func new tell, hey, in this project, put a new function, in this case, an HTTP trigger. So a function that will be run when you receive an HTTP call, a REST call, I don't know, a GET or a POST and so on. And then func start, take your functions and run in your machine. Let me go to the demo. I will show you. Let me open command line. Let me create a new folder. Okay. Okay. And now I want to create a new project for my function. Func init. I want to choose .NET 8. I can choose target framework. I can use, worker runtime, Java or Node.js or Python or PowerShell. I'm a developer, a .NET developer, so I choose .NET 8 as runtime. What is this one? In .NET, you have two worker runtime, isolated and in process. I suggest you, if you would like to try the function, to use the isolated. Isolated means the runtime of the function and your code run in different process. What does it mean? You can use library that are not supported by the function. If you choose the other one, not isolated, the other one, your code run inside the same process of the runtime. So if you try to use an old library, you cannot, because something wrong happened when they try to load the runtime, the library, sorry. And also, starting from now, you have only the .NET isolated. So this is the reason why I suggest you to use the .NET isolated if you want to write function in .NET. If you use Java, you don't have any problem. It's just, it is isolated. If you want to use Python, it is isolated by default, because Python is different from the runtime. Runtime is written in C#, so it's perfect. Let me write. Now the function, the func tool is creating the file for the project, the CS project, and another couple of files. Let me give some time in the meanwhile. Oh, okay, it's finished. Let me, as you can see, it creates the gitignore, the host JSON. It's important for the function, the CS project, the local setting, a program CS. Okay, this is the runtime, the bootstrap. Program CS is the bootstrap for the function. Now I want to create a new function, and I want to call it Queue Analyzer. Generally, when you have a demo, all the people create an HTTP function. I don't want, because you can find in other demos. I want to create a function that will be run when you put a message in a queue, just to be to create a different function. When you say I want a new function called the Queue Analyzer, the tool tells you, hey, what kind of trigger? This is the trigger you have built in. So queue trigger is I want to react when someone put a message on a trigger on a queue, HTTP, blob, timer. Timer means every 1 sec, every 1 minute, and so on. I choose this one. As you can see, you have event grid trigger. It's the trigger I will use to react from an event from an event trigger from an event grid events. And also, if you are a fan of Dapper, you have also Dapper, so the upper air. I choose this one. Let me create the function, and now stop with the command line. I go to the Visual Studio and open the project in Visual Studio. I want to run, so I need the or Visual Studio or Visual Studio Code, but I choose Visual Studio because I prefer. In the meantime, I drink. Come on. Let me check. Okay, perfect. Perfect. Now I open a project. I go to my temp, learning room, and CS project. Come on, you can go. 5 minutes and I will finish. Okay. So as you can see here, this is the bootstrap. Okay, it's okay. You don't touch if you don't want to add something like, for example, particular logs or dependency injection. In this demo, I don't touch anything. And this is the QAnalyzer function. As you can see, the function is a method, a snippet of code. Remember, if the function is a snippet of code. In C#, a snippet of code is a method. Okay. This is the name of the function. So the name of the method is not important for the function runtime. The important thing is the function name here, the function and the name. In this case, the name is QAnalyzer. This is the trigger. Q trigger means, hey, when the queue called the my queue items, let me rewrite this queue because I also have an emulator here. I am using the storage emulator and I have a queue called the source queue. So go here and I write source queue. Okay. And also, what is the connection? I can tell, hey, trigger, when you look for the connection to the storage, go to the configuration, local setting JSON or setting JSON if you are in the cloud, and take the connection called the property called the storage connection string. Then let me copy this one, go here, and add to the configuration. And because I want to use the local storage, I use this one. Perfect. So I'm saying, hey, when you look on the queue are in the local storage, in the local emulator. Of course, when you move to Azure, here probably you have a connection string of a real storage, right? But I want to run locally. Let me check. Let me put here a breakpoint and run. Now, what's happened? When you run in the Visual Studio, it's like you write func start. Func start is the command to run the runtime with your functions. In this case, only one function. So you have something like this. This is the runtime, Azure Functions Core Tool. This is the version, one only single function, QAnalyzer, QTrigger, and waiting for something. So I go to the storage here, source queue. I add a new message. And if it's all okay, come on, the function is started and the breakpoint is here. So I received the message. And if you look on this, quick watch, this is hi everyone. And this is the message I write in the queue. Perfect. If I go ahead, the message is pushed from the queue, and the queue is empty. So now the message is loose because I don't do anything. Just one thing. Now I want to use the binding. here to write a message in another queue, for example, I go here and write queue output. I would like to say to the function, hey, when you return, the return will be redirected to the queue that I told you. So here I put the name of the queue and also the connection string, exactly as I did for the trigger. Let me copy the name of the queue, output queue. Okay, perfect. Okay, and now here, message dot message text text dot to upper. So I take the message from the source, I calculate the upper, so I put in all the letter in uppercase and write in the other queue. Just a simple demo. To upper and then return new message. But now the return is not void, is string. So when I return a new message, because I say, hey, I want that the output will be redirect to the queue, the platform for me take the string and write on the queue. Let me check. Let me stop first of all, and then restart again. It's very, very easy. Now I show you the complete demo. 10 minutes and I finish, sorry. A little bit late, but it is funny, so.
It's no worries, yeah.
No, don't worry,
This
don't
is
worry.
awesome.
Okay, it's okay. Now go here, add a message. I don't remember if I put, yeah, perfect. I am here, so I continue. This is the source queue. It's empty. The other one, hi everyone again. So it's very easy. Writing the function is very easy. And also before I go ahead, let me delete this one, just because next time I don't want to have, I want to emphasize only one thing. Look on this. This is dependency injection. So if you want, and I will show you in the latest demo, you can inject your services. So the idea is you use this piece of code to orchestrate the services you want to use to as output. Or for example, you receive an event to Event Grid, then you call the storage and say, hey, undelete the blob, and then write and then send an email. If you want, you can use the binding as I did for the queue, but if you want, you can inject your service. So depends, okay? It's okay. Now, costs. As I said, you pay for the execution, and also you pay for the memory and for the time your function is running. So I suggest you to write function without lose memory, and your function must finish as soon as possible, because if you write a function that run 5 minutes, you pay for 5 minutes. But you have 1 minute of execution for free. So the same example of the Azure function, of the Event Grid. You have an Azure function connected to blob storage through Event Grid, and every time someone delete a blob, you restore the blob. Imagine your function will be called 1 million times from Event Grid. Okay, and I assume that your function occupy 512 megabytes. It's enough. It's a lot. Okay, it's a lot. 511. Okay, it's 12. Sorry, it's very, very high. So you need to use a lot of memory. Okay, and the duration is 1 second. 1 second is a lot to restore a blob. You don't need 1 second. But making this assumption, you pay $1.60 yeah, every month. So $1.04 for the Event Grid, and $1.06 for the function. So I think it's not so expensive. Okay. Connect the dots. And what I would like to show you, and you have the link, I will give you the link in the slide to the repository, GitHub repository. You have the code. The user delete a blob here, a blob in a storage, of course. The storage account throw an event to event grid. The event is blob deleted. The event grid redirect, push the event on my function, and then my function restore the blob, okay? Using the storage account SDK. It's very easy, but it is an automation because something happened in the storage, I react, do something, and recreate, restore the blob. So it's, I show you. First of all, I go to to Azure here. Okay, let me restart this one. This is a storage. Okay, you can see. Let me close this one. This is a storage called. This is the resource group that contains my function, that contains the topic, the subscription, and the storage. This one I'm looking for. The deletion. I go to containers here, documents. This is the cover of my book about durable function. You can find out succinctly. It's free, but I don't like it, so I delete. Okay. This is the event, blob deleted. And if I refresh, now arrive the blob. So the event is thrown from the storage, routed by the event grid to my function. Need some time because my function is not running, are removed from the memory. This is the cold start. So the function started, take the data from the event, go to the storage and say, hey, undelete that blob. If I do now again, probably I have immediately because now the function is starting, is running, is in memory. Okay, but yeah, it's okay, I think. If I look on the code, this is my function. As you can see here, I inject the logger, I inject the configuration. If you are familiar with ASP.NET, exactly the same. The platform for the injection is the same. From dependency section is the same. I also inject my persistent managed service. I don't do the operation of restore inside the function. I call an external service, my class, the class is persistent management service, because if I need to change the hosting to remove, I don't want to use the function, but I want to use another technologies, I don't know, a container, another one, not serverless. I take my class, the logic, and put on the new one. So here I receive the event, I serialize the event in a data and then call the undeleted blob. Three lines of code. Of course, there's not three because here you have more than three, but yeah. No, sorry, go to the implementation. I use the blob client. Yeah, 3 lines because I use the blob client. I call the undelete. Of course, my function has an identity, a managed identity, and I have the right role on the storage first. Second, on the storage, I enable the soft deletion, because if you don't have the soft deletion, when someone delete the blob is destroyed. Okay, just to show you, I go to the storage here, and I go here. This one. So for 7 days, probably one is enough. But if I delete a blob, it remains in the garbage for 7 days. Otherwise, the blob will be destroyed immediately. If I try to make undelete, I receive an error. But it's easy. So 3 lines on a part. I need to connect with the event grid, and that's all. just to close, we'll see the cost. The cost is $1.06 for the function, and I don't have a summary. And $1.14 for the $3. It's enough to manage 1 million of deletion in my storage. I spend $3 in a month, so it's quite cheaper. So then, for the first part, I finish. Next time we will see the alert and logic up. If you have any question, this is my my reference, the mail, and also LinkedIn. And when you will download the slides, you will have also the link to the GitHub repo and to the documentation, learning path, and also all the other information. Any question?
That was great. Thank you. For the people attending or watching this, I'll be putting the slides into like the learning room Teams channel, and you can grab it from there. I'll put the link in the channel. But yeah, that was great. Thank you very much, Massimo, for coming and talking to us today.
I'm sorry for the 7. I'm sorry for the 7 minutes late, but yeah.
Oh,
I'm sorry.
It's all good. It's those kind of last minute. Oh, my camera's not on. Those kind of last minute tidbits are usually, where the real world stuff comes into play. So it's really good to capture that. The only questions that we really had was mainly about the recording, and yes, the recording will be put up. Some people had to go because we've just passed our other meetings and things like that as well. But is there any last sort of tips on working with these functions day to day that you just want to end on, or have any thoughts about that you can give these students?
I don't know if they have any question. Just a couple of tips from my side. When you the functions are very easy. If you see the demo, you see that the function is just a piece of code with one trigger, some bindings. But pay attention, because if in your project you add a lot of libraries, you waste a lot of memory. And if you waste a lot of memory, you pay, because you pay for the product between memory and duration. So if you put some library that occupy memory without using, you pay a lot. So keep the function skinny in memory and also in time. If you need to do something that run for 1 hour, probably is not the best to choose the function. You can use other, or you choose a batch, but the function, remember, you pay for the duration, multiply for the memory. So if your function run for 1 hour, you cannot run a function for 1 hour in a consumption plan, but in the other you pay for the duration. So it's not a good idea to run a function for a long time, in my opinion. Anyway.
I think that that goes into durable functions and other mechanisms as well. And cold start is usually where I've run into problems with functions in the past. And I know the Microsoft product teams have been doing quite a lot of work around that.
I agree with you with the durable function, but you use the durable function when you need to implement a workflow. But when you have, I don't know, I see some people that use function to run every midnight to, I don't know, clean a database. You can containerize your simple console application and run in a container instance instead of using the function, because it's not you run one time a day for 2 hours. It's not a good idea to use a function, in my opinion. But anyway.
I think we I always find it quite interesting from an IT operations background as well, because my like that scenario of cleaning up a table or something in a database, yes, you could go and do it with Azure Functions, but you could also do it with like an Azure Automation runbook as well. So yeah, it's
Perfect.
it's
Exactly. You can create a runbook and then say, "Yeah, I want to schedule the runbook at midnight." It's a great solution. I never use a function for something that runs for more than 1 minute. Or
but I think
if happened, I try to write with the workflow using durable function, but not with the function.
Yeah, I think you captured it really well in the original, introduction as well, about using functions for your business logic. It's all about, using it to achieve business outcomes versus the, those maintenance tasks that you're talking about. So
yeah.
Yeah, thank you very much. I think we'll end it here, but thank you very much for coming and presenting this amazing topic today. Thank you for taking the time at 11:30 at night. It's probably almost past midnight now, to come and talk to us about functions and Event Grid. And yeah, we look forward to the next session around.
I wait you for the next session.
Yeah, and in 2 weeks' time, we'll have the Azure Monitor and Logic App session. So yeah, quite looking forward to that. But thank you for spending your time and coming in. We've got some thank yous in the chat. So
thanks again, Luke, for invitation. It's a pleasure for me. It was a pleasure.